Today we're going to look at finding the y-intercept and the x-intercept. And these are just special points on our graph. So we're going to start by looking at this graph here. And there's some special points on it. And they occur when our graph, our linear equation, goes through the y-axis. And notice that that happens right here. And when it goes through the x-axis. And notice that that happens right here. So I'm actually going to label these points because they're special. So if I start at my origin, notice that to get to the line, to the linear equation where it goes through the y-axis, I'm going horizontally 0, and I'm going vertically 1, 2, 3, 4. And then for the point where our linear equation goes through our x-axis, I'm going to go horizontally backwards 2, and I'm going vertically 0. So these are two special points. All right. So what we call the y-intercept, okay, this occurs when our graph, our linear equation, goes through the y-axis. Okay, so our y-intercept occurs when it goes through the y-axis, and that's the special point 0, 4. And this is always going to happen for when our x value is 0. The x-intercept is a point where the graph goes through the x-axis. Okay, so x-intercept goes through the x-axis, and notice that our point here, the value for y, and it always is going to be 0. All right, so if I want to determine the x-intercept and the y-intercept for above, so our x-intercept is where the graph goes through the x-axis. And you can always, if you're not sure, you can always just look for the x-axis, and then you can draw a line through it, and then when you finally get to that point where the linear equation goes through it, that's your x-intercept. So our x-intercept in this case is -2, 0, and our y-intercept, which is right here, it's where our linear equation goes through our y-axis, is 0, 4. Let's do a few more. All right, so we want to determine the x-intercept and the y-intercept for the following graphs. So I'm just going to put for all of them x-intercept here and y-intercept. So for our first graph, to find the x-intercept, if this helps, you can just draw a line until you get to where the linear equation goes through the x-axis. And now we just have to label it. So horizontally, I'm going in the right direction 3, and I'm going vertically 0. And for my y-intercept, I can start at my y-axis, and I can draw a line right until I get to where the linear equation goes through the y-axis. And this occurs when I horizontally go 0, and I go up 3. Okay, our next line, and this one's a little bit special. So for our x-intercept, again, I'm going to start with my x-axis, and I'm just going to draw a line along the x-axis until I get to it. And this point occurs when I go horizontally 1 over and vertically 0. So my x-intercept occurs at 1, 0. Now in this one we have a straight line, and the straight line goes along x equals +1 the whole time. It's never actually going to cross the y-axis. And therefore, we would say that it does not exist. For short, you can write DNE. Okay, so for C, we're going to look for our x-intercept first. But what I want you to notice is that we have a line here that goes through y equals +1. And it's a horizontal line. In fact, it's never actually going to cross anything except for y equals 1. And therefore, there is no x-intercept. It's never going to cross the x-axis. So again, we have this does not exist. For our y-intercept, however, we do have a value. It goes through right here. And this occurs horizontally, it's going 0. Vertically, it's going 1. So we would say our point is 0, 1. All right, so question, what if you do not have a graph and are given a linear equation instead? Well, let's just look at what happens with our x-intercept. I'm going to write x-int for short and y-int for short. So if we look at our x-intercepts from above, notice that our value for y is 0. So the value of y, when we set this above, are always 0. Which means that if I had an equation, I could always find the rest of the point if I substituted in y equals 0 to find the x-intercept. And for the y-intercept, notice that our values for x are 0. And this is true always. The values for x are always 0. And this means that when I have a linear equation, I can always substitute x equals 0 and find the rest of the ordered pair for whatever the value of y is. And we're going to conclude that now. The x-intercept occurs when y equals 0. The y-intercept occurs when x equals 0. Okay, so let's do some examples. So I've done these both in slope-intercept form, but they might be in a different form as well. So if I'm trying to determine the x-intercept first, it doesn't matter which one you find first. Let's just do x-int. And the x-int occurs when y equals 0. So that means that I'm going to get, for my equation, y equals 2x plus 3. I'm substituting 0 in here. Now I'm trying to solve for x, so I'm going to have to subtract 3 from both sides. I get negative 3 is equal to 2x, divide by 2, divide by 2, and I get x equals negative 3 over 2. So my point, my x value, remember it goes in alphabetical order, is negative 3 over 2. My y value is 0. I'm going to shrink this a bit so I have a little bit more room. There we go. And now we want to find out what the y-intercept is. And the y-intercept occurs when x equals 0. So I've got y equals 2x plus 3. Y equals, and the y-intercept occurs when x is 0. And 2 times 0 is 0, which means that y equals 3. So my y-intercept occurs when x is 0 and y is 3. Okay, so this is my x-intercept, this is my y-intercept, and that's what the question asked. Let's do it again for B. So I'm trying to find my x-intercept, and this occurs when y equals 0. So I have 0 equals negative 3x plus 7. Now I'm trying to solve for x, so I'm going to have to subtract 7 from both sides to get x by itself. And then I'm going to have to divide by negative 3 on both sides. And negative 3 divided by negative 3 is 1, so I get x equals, and a negative divided by a negative is positive, so 7 over 3. So my point occurs when x is 7 over 3 and y is 0. And this is my x-intercept for this equation of the line. And now I want to find my y-intercept, and this occurs when x equals 0. So I end up with my equation, which is y equals negative 3x plus 7. And in this case, my x value is 0. Y equals negative 3 multiplied by 0 is 0. So I get y equals 7. So my point, my y-intercept point, occurs when x equals 0, y equals 7. Excellent. All right. So I want to do a little bit of a comparison here. So let's first look at the equation y equals 2x plus 3. And I want to compare what the y-intercept is. So my y-intercept for this one we found was 0, 3. We can even just write there. So this was my y-intercept is 0, 3, and this occurs when x is 0 and y is 3. What I want you to notice is that. And that kind of makes sense, right? Because if I'm putting x equals 3 in here, or sorry, x equals 0 in here, then 2 multiplied by 0 is 0. Let's look at the other one too. Y equals negative 3x plus 7. And our y-intercept was 0, 7. And again, notice that this number here and this number here are the same. And again, that makes sense because I'm plugging 0 in for this, and so this becomes nothing. And 0 plus 7 is just 7. You can always conclude that when we have our equation of our line in slope-intercept form, and it has to be slope-intercept form, then the y-intercept equals the constant value. And we're done.